Assalamualaikum, my name is Nur Isati Balkis Mentodomain. Today I want to show to you process for making experiment in lab 3 for part A and part B. And go to friction, and then at first we need to change apply for 0 Newton to 50 Newtons. And then in a 50 Newton, we got friction force is 50 Newton in left direction, apply force in 50 Newton right direction, and sum of force is 0. So all the result we need to put in friction properties in step 1. Next, we need to change from 50 Newton to 105 Newton. So change 105 Newton. For 105 Newton, we got a friction force for 64 Newton in left direction, 150 apply force 150 Newton in right direction, and sum of force is 56 Newton in right direction. So the result we need to put in experiment data result in step 2. And then we need to add one more 50 kilopascals here and change the 150 Newton to 500 Newtons, and we got friction force is 188 Newton in left direction at in step 3A in left direction.
Okay, in a part B, we need to click this link and set angle is 0, 10 kilo, and this is 0.5. Okay, move. Okay, for M1 is 2.5 kg, M2 cannot be moved, right? So we plus 1, 2.6 kg, M2 speed is slow, so we take the 2.6 kilogram and put in the table. Next, we go to 8 kilogram. M2 still can move, so M1 for 8 kilogram is 2.1 kgs. So we put to 1.1 kgs in table B. 2.1 kgs. Next is 6 kgs. Right, and 2.1 kg, M2 can move fast, can move, okay, cannot move. So for M1 in 6 kg is 1.6 kg. 1.6 kg. Okay, 1.6 kg. For 5 kg, 1.6 can move, 1.5 can move, so can move, cannot move. So for kg is for M2 for kg is M1 is 1.1 kg because it can slowly move, but 1 kg cannot move. So one kg. So for M2 is 2 kg. 1 kg. M2 still can move. So M2 I put 0 because it's under the rate. Which means 1 kg, M2 still can move, so we don't have a value less for 1 kg.
Okay, so today we are going to do part B, table 3. Okay, first we need to change the data to the 0 degree. Then the weight M2 is 10. Okay, now we need to okay this we need to change the coefficient of frictions to the 1.0. Okay, the M1 is the maximum, we try at maximum, so it is 10 kilogram. Okay, so what we need to observe from this experiment is the moving of M2 here towards the M1. So M2 will be moving along this horizontal incline. Okay, horizontal 0 degree incline. Okay, so we need to run the test. So what we see here, there is no changes at all. So we need to reduce. Maybe it can, maybe M2 can move. So we try to reduce the M1. Okay, so we can see that the maximum. So we can see that the value of M1 need to move the M2 is greater than 10 kilogram. Okay, is greater than 10 kilogram. Okay, so we so after that we from the table below from the table we can see that the M2 is 8 kilogram. Okay, we try for 8 kilogram. Okay, so the 8 kilogram we can test it at 10 at M1 is at 10 kilogram. So they are moving too fast. Okay, we need to turn it slow. Okay, in over. Okay, okay, it is not moving. So it is moving, but it's slowly. It is moving. So the mass of M1 need to move the M2 is 8.1 kilogram. So after that we put M2 in 6 kilogram. Let's see what happens. Okay, for 6 kilogram, it moved too fast. Too fast. Okay, so it do not move at all. So we add 1 kilogram, and then we can see that it is start moving slow and slowly. Okay, the value of M1 for moving the M2 in 6 kilogram is 6.1 kilogram. Okay, we are moving to 4 kilogram of M2. Okay, okay, let's see what happens. Uh, we can see now that M2 is moving. Not moving at all. Okay, okay. We can see now. We can observe this is moving towards the M1. Uh, so the M2 for kg is equal to M1 to 4.1. Is able to move the M2. Okay, we can try for the last one for part B. Table B3, we can move to 2 kilogram. Okay, for 2 kilogram, let's see what happens. Okay, this is for 2 kilogram. Okay, you can see now that M2 is not moving at all, and we can plus 100 gram. Okay, you can see now it is moving. Okay, so the value of M2, the value of M1 need to move the M2 is 2.1 kilogram. Okay. Okay, we are moving now to the table for part B and table B4. Okay, for the table B4, okay, we need to change the theta to the 30 degree. 30 degree, 30 degree. Okay, for the 30 degree, then the weight is for M2 is still 10 kilogram, like the table B4, like the table B3. Okay, the coefficient of fraction of COF is still 1.0. Okay, the mass, I don't think this is, okay, we can try at 9 maybe. Let's see what happens. Okay, we can see that there is no moving. No M2 is not moved at all. Okay, we can add. Oh, unfortunately, there is no move. So the M2, the value of M1 need to move the M2 in 30 degree is greater than 10 kilogram. Okay, we need to move to 8, let's see, I think 8 kilogram for M2. Okay, okay, at kilogram. Okay, we try run at night. Oh, 9. Oh, do not move at all. So we can observe that 8 kilogram of M2 need M1 need value is M1 need a greater value greater value need greater kilogram, need more than 10 kilogram to move the 8 kilogram of M2. Okay, okay, we move to 6. Let's see. Okay, let's see what 6. Oh, it's moving. Let's see what happens. Okay, you can see now that the M2 is moving, but it is slow. Let's see once again. Okay, you can see now. This is M2. I put the marker here. Yeah. Okay, it is 8.3. You can see that already. So we move to um, so we move to 4 kilogram. Okay, 4 kilogram. Let's see what happens. It's moving too fast, too fast. Okay, for okay, I think this is 5. Okay, it's 1 more. Okay, you can see now the M2 is moving. Okay, the M2 is moving, so it is 5.5. Okay, it need 5.5 kilogram to move the 4 M2 or 4 kilogram in 30-degree incline. So we need to move to 2 kilogram. Let's see, 2 kilogram. For 2 kilogram, let's run. Oh, it's moving too fast. Oh, fast, very fast. Okay, not moving at all. Let's see. Okay, it is for moving 2 kilogram of M2 in 30 degree, we need 2.8 kilogram of M1. Okay. You know what? For the calculation of M2, we cannot put F equal to MA, like M2 2 kilograms times 9.81 for gravitational acceleration. No, we can not use that because it is 30 degree here. So if it is 30 degree, it free body diagram is like this. So if 30 degree here means this here is 60 degree, right? So if it is 60 degree, it means that this is 30 degree. If this is 30 degree, it mean m mass times gravitational acceleration, means gravitational force equal 9.81 time cos theta, cos 30, I mean cos 30. Uh, so that you can get the what we call the force of 2 kilogram. Uh, if you want to get force for 4 kilogram, it's actually the same. Like this is 60 and the other line, if this is 30, okay, then mg mass times gravitational force times cos 30, then you can get the absolute value for the force up. Okay. uh, okay, for the graph, you for the graph you can do the graph by doing the Microsoft Excel. Okay, for the if you want to find the coefficient static friction, is actually you need to uh, y2 minus y1 over m1 minus m2. Okay, it is actually a gradient. So if you want to find the gradient, you need to find the point and the point, uh, the gradient. Okay. So for the question, okay, state what you can observe from the value of COF. If the value COF is lower, then the overall friction is lower. So the COF depends on the type of surface, whether it is smooth or rough. Rough. Okay. So state the regarding types of material. Okay, when the material surface is rough, the COF is low. When the material surface is smooth, the COF is high. Okay, the main error that will affect the result from the experiment is when the performing the experiment, systematic error is made by taking incorrect reading of observation or measurement, especially when taking the angle of measurement. So when you take the measurement angle, your eyes must be perpendicular to the angle that you want to take. And then after that, you need to, when we have a deep theta in incline, we need to use mg cos theta. If you do not use the formula, you will get the wrong answer for force. Okay, that's all from me, Muhammad Zain Iqbal. Thank you, everyone. Okay, bye.